Hello friends, we are back with NCERT Chapter 14 Electric Current and its Effects Part 2 for Class 7. We have already done the heating effect of electric current in the previous video. In this video, we will understand the magnetic effect of electric current. To understand this, we will perform a simple activity. We set up a simple electric circuit on a table with a cell, its two ends connected to a wire and a switch. On keeping a magnetic compass near the circuit, we find that the needle is pointing in the north-south direction. On switching on the circuit, electric current starts flowing through the circuit and it is observed that the needle of the compass gets deflected from its rest position. When we switch the current off, the compass needle comes to the rest position again. So we conclude that when electric current flows through the wire, it behaves like a magnet. This is the magnetic effect of electric current. It is observed that if the direction of the current is changed by reversing the connection of the cell, the needle gets deflected in the opposite direction. If the amount of current is increased by adding one more cell in the circuit, the angle of deflection increases, indicating that the magnetic power increases with the increase in the amount of current. Scientist Hans Christian Ørsted was the first person who noticed the deflection of compass needle every time current was passed through the wire. What is an electromagnet? Now, electric current can be used to make magnets. Take an iron nail and wrap a number of coils of wire around it. Then connect the two ends of the wire to a source of electric current, a cell or a battery, through a switch and allow the current to pass through it. We will observe that the iron nail behaves like a magnet with its two ends acting as north and south poles. If an iron clip is brought near its end, it gets attracted to it. A magnet formed by such an arrangement is called an electromagnet. Therefore, an electromagnet acts as a magnet as long as electric current passes through it. It loses its magnetism as soon as the current stops flowing. An electromagnet is also called a temporary magnet. The strength of an electromagnet can be increased by increasing the number of coils, increasing the strength of the current, and winding the wire around a magnetic material. What is a solenoid? A solenoid is a device in which a long insulated wire is wound around a hollow metallic core. It is cylindrical in shape. A solenoid can be used as an electromagnet. Electromagnets are used to lift heavy iron articles like cars in a workshop, to separate iron or other magnetic materials from a garbage dump, in loudspeakers, in telephones, electric fans, washing machines, in refrigerators, in toys, in electric bells. Doctors use tiny electromagnets to take out small pieces of magnetic material that have accidentally fallen in the eye. Now we will understand the working of an electric bell. The doorbell or the electric bell makes use of the principle of an electromagnet. A horseshoe type of electromagnet is used, which is connected to the source of current through a switch. This is the switch and this is the source of current, a cell or a battery. An iron strip with a hammer at one end is kept close to the electromagnet. There is a contact screw near the iron strip. The iron strip is in contact with the screw. When the bell is pressed, the current flows through the coil, which becomes an electromagnet. It then pulls the iron strip. You can see the arrow here. The horseshoe magnet pulls the iron strip towards it. In this process, the hammer at the end of the iron strip strikes the gong of the bell to produce a sound. However, when the electromagnet pulls the iron strip towards it, it also breaks the circuit. You can see it is no longer in contact with the contact screw. The current stops flowing through the coil. It no longer attracts the iron strip. Now the horseshoe magnet no longer attracts the iron strip. The iron strip comes back to its original position and touches the contact screw again. This completes the circuit. The current flows through the coil and the hammer strikes the gong again. This process is repeated in quick succession. This is how you hear the sound of the bell. Thank you for watching the video. If it has helped you in any way, please like the video and subscribe to our channel for more such videos. Thank you.